Hello. Okay, so I am going to talk about the fire triangle for my kitchen chemistry. So, for fire to be able to burn, we basically need fuel. So I've got a candle here to be my fuel. We need heat. So I've got a spark from a lighter. And then we've got oxygen in the air. So we've got fire. Perfect. So if we remove any one of these three elements for the fire triangle, we will lose our fire. The fire will go out. So to show that, I am just going to cover this up with a glass. So we're stopping the amount of we're basically eliminating oxygen, fire goes out. Makes sense. Okay, so just to take this a step further, what I'm going to do, move that in a second. So basically I've got a plate here that's got water with food colouring in it, just so it's clearer. And then I'm going to burn the candle again. So fuel, heat, oxygen from the air. We've got fire. So then what I'm going to do is I'm going to cover it with a glass this time. Oops, it's just gone out. This candle's a bit wet, I'm just going to swap over. Okay. So, fuel, spark, oxygen in the air. We've got a burning candle. So I'm going to cover it with a glass, and basically I've got water and food colouring in the bottom, and then let's just see what happens. So the candle will burn and use up the air that's in use up the oxygen that's in the jar, and then when the candle goes out, can you see that green level, the liquid level, has just climbed up the jar? So I've drawn lines on the jar, and this shows that basically in the jar of air, 20% has been displaced by water, so that means our 20% oxygen has been used up in burning for the candle, which ties in perfectly. Let me just show you this. Move that. With this slide here. So the air that we breathe has 21% oxygen. So when a fuel is burning, it's using the oxygen in the air, and we've just shown in this experiment here that 20% of the oxygen in the air was depleted. Okay? So back to our fire triangle. If we remove any one of these elements, our fire goes out. So if you think about fire extinguishers, if we are spraying water on a fire, we're trying to cool it, so we're trying to remove the heat so that our fire will go out. Or if possible, if it was a fuel, a fire that was burning where we can remove the fuel, so for example turn off a gas, that would extinguish the fire. But for fire extinguishers, a lot of the times we're trying to remove the oxygen. So this we would often do by using a foam fire extinguisher, where we get a blanket of foam to suffocate the fire to remove the oxygen. Or we have carbon dioxide fire extinguishers. So again, removing the oxygen to put the fire out. So I'm going to do an experiment now just to make some carbon dioxide, and hopefully then I can show you some properties of carbon dioxide. So what I've got is I've got baking powder set up in a jar, and then using some environmentally unfriendly straws, which are in the back of my cupboard, I have set this up to try and collect the gas. So I'm just going to pour vinegar in here, and then we'll look for signs of a chemical reaction. So try to be quick. So the idea is that we get all this fizzing, carbon dioxide gas is made. It should be collecting through the tubes, through the straw. And then the carbon dioxide should collect on the other side. So hopefully carbon dioxide is collecting in here. Carbon dioxide is quite a dense gas, so it should be sinking to the bottom of this glass jar here. So let's try it. Okay, so if I've got a fire, you can just about see. It's the wet one. Okay, let's try this candle. And then, if I've managed to collect carbon dioxide, I should be able to pour an invisible gas. Did you see that go out? Managed to collect some. So the carbon dioxide gas is quite dense, it sits over the flame, stops the oxygen being available to burn, and then puts out the fire. And that's me. Thank you.